Our next unit that we're doing is the application of the exponents that we've already done. We're going to start with scientific notation. There is something called regular notation, and usually we don't call it regular notation, we call it standard notation. Please make sure that you are taking the notes on your packet that you've been given. So the standard notation that we write are numbers. So 208 million is written as 208 million. Yes, you need all those zeros. Now, scientific notation is a condensed way I spelled it wrong, sorry. Of writing really large or really small numbers. SN, or scientific notation, is a number that can be written as a product. That means multiplication of two factors. Example, the 280 million, no, up above it was 208 million, this time it's 280 million, can also be written in scientific notation as this: 2.8 times 10 to the 8th power. Now, if you look right here, amazingly, it's the same information. The first factor, this factor right here, this very first factor, 2.8, a number that is between 1 and 10. It may not be a decimal. Sorry, it may or may not be a decimal. So like this one is 2.8. This time around it has a decimal. Then the second factor is always a power of 10. It's always a power of 10, so it will be 10 to some power. The power of the exponent tells you how many places to move the decimal spot. Oh, I don't. The sign of the exponent tells you which direction, I know, which direction to move it. Now, normally I will never say move left or right. I will say if it's a big number to start off with, then it needs to end as a big number, and vice versa. If it's a small, then it needs to be small. This worksheet or notes packet does talk about if you move to the left or right. If decimal is moved to the left, going from standard notation to scientific notation, the exponent will be larger. If the decimal is moved to the right, the exponent will be smaller. So, if I look at these numbers down here, they are very large looking. Now, some of them are actually very large and some are very small. They just have lots of zeros. So we don't want to always deal with those big numbers, and so we need to make them look a little bit more manageable. And so what we're going to do So we're going to take this number, and the very first thing we have to do is we have to get it to look something similar to this, meaning the number on the left-hand side of the decimal has to be between 1 and 10 or 1 and 9. So this should say 4.2. Automatically, it's 4.2. Then, and I must have times 10 to some power. Because it says 0.2, that means I need to move this decimal point over until it gets to here. So I'm going over 1, 2, 3, 4, 5. Now this is 420,000. That is a very large number. So that means the exponent over here is actually going to be positive. Okay, the larger the number, the exponent is going to be positive. So we moved it over 1, 2, 3, 4, 5 times. So my exponent is 5. The reason that it's positive is because this number right here is a big number. Then let's go to the next one. Again, this is a humongous number. That means when we do times 10, that exponent is going to be a large number. It is not going to be negative, it is going to be positive because positive is larger than negative. So we're going to get 7.35 because the number on the left-hand side of the decimal needs to be between 1 and 10. So I move it over 1, 2, 3, 4, 5, 6, 7, 8. I moved it over 8 times. My exponent is a positive 8 because that number is larger than 1. It is a big number. Now if I look at this next number that we're going to do, the next number we're going to do is actually smaller than 1. So that means instead of having a positive exponent, I'm actually going to have a negative exponent. So the very first thing I'm going to write down here is 10 to the negative power. I don't know what that negative is going to be right now, but I do know it's going to be negative. Again, I know it's going to be 8.97 because this digit right here has to be between 1 and 10. So I move it over. I go over 1, 2, 3. I moved it over 3 times. But because that number is smaller than 1, my exponent is a negative 3. Not a positive 3, but a negative 3. This next one. Again, this number is less than 1. So I know it's going to be 10 to the negative power. I know that it's 1.4 because this number has to be between 1 and 10. I move it over 1, 2, 3, 4, 5, 6 times. So it is 1.4 times 10 to the negative 6. I actually want to go to the back side of this, right here. Now there are some more notes at the top, but we're going to do those in a minute. I want to do this down here. Just want to do the bottom part. We're going to do a couple of these together, and then I will have you work on the others on your own. So first, I want you to do number 1 and number 5. Okay, that should be 4.5 times 10. Now I'm looking at this. This is bigger than 1, so I know it's going to be a positive. So my decimal point is going to go here. I'm going to move it over 1, 2, 3, 4 times. So that would be to the positive 4. If I look down at this one, I know that that's going to be a negative exponent because that number is less than 1. If I'm going to say 5, and you can write 5.0 if you want. You move that decimal over 2 times, but it is a negative 2 because of the direction that you did. Now, we'll do one more together of each of these, and then I'll have you do the rest. I'm going to pick number 3. Again, that's going to be a positive exponent. So 7.45. And you can put the 0 if you want, but you don't need the 0. I moved it over 1, 2, 3 times. So my exponent is 3. Then I will come down here and I'll do number 9. Now, number 9 is an interesting one. So my exponent is going to be negative. On this one, they have all these extra zeros in between. Guess what? I have to write those zeros. Bring it over one time. 1.89000097. The reason I have to write all of them is because they're in between those two 9s. I only moved my decimal over one time in the negative direction. You do the rest of those. And here are the answers to those. And now we're going to look at scientific notation to regular notation. So now we're going the opposite direction of what we have just done. So if the exponent is positive, move the decimal to the right. Now, again, when I think of this, I don't think of it like that. I say, if the exponent is positive, then you have a large number. That means it's going to be larger than 1. It's going to be larger than 10 most of the time. Then, over here, if I have a negative, then this number is actually going to be, amazingly, smaller. So it's actually going to be smaller than 1. And you'll move it to the left, but I don't care about that left-right thing. So now I look at this problem, these problems right here. If I look at those, I notice, guess what? This is a large number because this exponent is positive. So I'm going to move that decimal over 5 times. Now I'm going to actually use my little space over here, 7.5, and I need to move it over 5 times. So I have 1, 2, 3, 4, 5. And I put in zeros to be my placeholders. 7, 5, 0, comma, 0, 0, 0. That is my answer. Where the loop-de-loos are, that is not my answer. I need to write it out. Again, this one, guess what? It is also a large number. So I write the 3.8, then I move it over 4 times. 1, 2, 3, 4. And I put in my placeholders and I get 38, comma, 1, 2, 3. So 38,000. This next one, it has a negative exponent. So this is going to be a small number. It's going to be a small number. So when I do this one, 4.2, I'm actually going to make it smaller than the 4 that it already is. And I'm going to go to the left negative, or I'm going to go to the left 3 times. 1, 2, 3, and put a decimal spot. So I have to put some placeholders. So 0.0042. Last but certainly not least of these up here, again, this is a negative exponent. So that means it's a small number. So it's actually smaller than 7.51. So I write 7.51, and I'm going to go to the left 5 times. 1, 2, 3, 4, 5. And I put some placeholders in here, and I get 0.000751. Okay, excellent. I look down here. Let's do some practice of that. So I'm going to have you do, again, let's do number 1. Just do number 1 and number 2. Okay, you should have noticed that this is a small number. So there's not a lot of space here. So I'm just going to do here 9.46 and go 1, 2, 3, 4, 5, 6. Over here. Sorry, I couldn't count and write at the same time. This one, look at this. It has a positive, so I know that's a large number. So 2.5, I'm going to move it over 3 times. 1, 2, 3. How did I know which way to go? Because I wanted it to be a large number, not a small number. Okay, I'll do a couple more with you and then I'll have you do the rest. 1.6 is a small number because it has a negative exponent. So 1.6, and I'm going to make it smaller than 1.6. Go to the left 2 times. So I have 0.016. And then I'll do number 4 with you. Positive exponent, so that means it's a large number, so it's larger than 4. So I'm going to move this over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I have 400,000. Okay, go ahead and do the rest of those. And here should be your answers.